right, ladies, let's take a look at today's lesson. We spent last lesson talking about inverse trig functions, so I just want to just scroll up there for just a moment just to remind us what we focused on last time. We focused on the concept that the arc functions, we need to make them function, so we had to put restrictions in place. The restrictions that we talked about, I think, are visually, you know, I like to look at the picture. I'm a very visual person, and so looking at this picture visually it kind of makes sense to me. So we talked about arc cosine, arc cosecant, and arc secant being in the first and second quadrant, you know, positive in the first quadrant, negative in the second quadrant. We talked about arc sine, arc tangent, and arc cosecant being in the first and fourth quadrant. We also talked about how you have to go backwards to get into the fourth quadrant. You can't rotate through the third quadrant. So we talked about that. One thing that I would like to point out is I think the arc cosine and the arc sine and their reciprocals are pretty straightforward, but the cotangent and tangent can be very confusing. So I'll just explain how I think of it. So the arc cotangent, I think of it being with arc cosine, cosine, cotangent. They both start with a C, so they behave the same way in the same quadrants. And then I like to think about the arc sine and arc tangent behaving the same way, that they, arc sine and arc tangent, behave the same way. So I kind of link them together in my brain so that I can figure out where the cotangent and tangent should be for the inverse functions. Just kind of a little hint if that's a problem for you. So let's go back and let's look at the other three. So this last time we basically dealt with arc sine, arc cosine, and arc tangent. This time we're going to deal with the other three, arc secant, arc cosecant, and arc cotangent. So we have this note down here. So this is still applicable. Those things would be equivalent, you know, just a example. This whole thing is reference material for you. So let's talk about some of the particulars in here. If we look at arc secant and you see this right here, think about what we just talked about. Arc secant is the reciprocal of cosine. It's supposed to be in the first and second quadrant. That's why the range is from 0 to 2 pi. I mean, that relates this data to something that hopefully is in your mind. You know, where is arc secant and arc cosine supposed to be for function values? We're just, you know, thinking about function values. Cosecant, or arc cosecant, that's reciprocal of sine. We know that is in the first and fourth quadrant. So you can see where this value is negative pi over 2 to pi over 2. Okay, and that relates to what we've been talking to. And lastly, arc cotangent, that one I pair with cosine, so that's in the first and second quadrant, which correlates to this data that they have here, that the range is 0 to pi. So I just wanted to tie this into the visual picture that we have for where all those arc functions reside for their function values. Okay, are there any questions so far? All right, so let's look at, we have 5 examples on the next page. 5 examples, so let's look at that. Okay. These are similar to what we did last time, but last time we were working with the other three arc functions. This time we're working with secant and so forth, arc secant. So let's think back. If this number in here is positive, then we know we're in quadrant 1. Okay, we know our answer needs to be in quadrant 1. Okay, just so we're clear, that's just from our little diagram from previously. If you don't like looking at it like arc secant 1 is theta, you could rewrite it, and a lot of students really don't like that format, and they would much rather say secant theta is 1. And hopefully we recognize that these are inverses of each other, And the only thing that has been done is the x and the y have been flipped, right? That's their inverses. So you can write it either way, whatever is more comfortable for you. It doesn't really matter. I think, let's just look at secant theta as 1. All right. So the question we're asking ourselves is, where is secant equal to 1 in quadrant 1? I mean, that's what we want to know. Now, secant is the reciprocal of cosine, so that's something that you would need to remember. So it would be the same as cosine equaling 1. It would be the same, because reciprocal 1 is just 1. So let's so unit circle is something you're going to have to know. We're going to be in the first quadrant. We need to figure out, so let's see. So secant is the same as cosine. So cosine maps to the x. So we want the x to be 1, which puts us right here. That's where x would be 1. We know that coordinate point is 1, 0. And again, cosine maps to the x. So our answer is going to be basically 0 radians. You could write 0 radians if you want to, or you can just write 0, because that's where that would be true. Okay, I want to pause here for just a second. Are we okay?
Why is it 0 not 1?
It's the angle measure, 0, or 2 pi. It's like 0 degrees, but we're in 0 radians. So it's not the coordinate point 0, it's the angle measure 0. Okay? Other questions? Yes, ma'am.
Sorry, why does it go to same as cosine?
Because secant is the reciprocal of cosine. Okay, so secant equals 1 over cosine. And so for me, it's easier to find cosine values than secant values. That's just easier because cosine is x. And so I just find the cosine value and then I flip it upside down. And so this cosine value flipped upside down is just still a 1. Okay, so I would take the secant value, whatever secant is. Let's say it wanted just an example. Let's say an example said, where is secant equal to 2? Well, what I would do is I would figure out, where is cosine equal to 1/2? Where would that be? Because that's easier for me to think of with the unit circle than where secant is. I haven't really memorized secant values, but I have memorized cosine values. Does that make sense? Okay. Any other questions on the first one? Okay, on the second one, we're going to, again, look at the sign. Right? This number is negative. So we need to think about, where is cotangent, or the inverse cotangent, negative. So cotangent, I think in my mind, goes with cosine. So I'm looking at the second quadrant. This is where I'm supposed to be. Okay, so that's where I'm supposed to be. Now I need to figure out, so we know cotangent, so we got some background work to do before we can actually work this problem. Cotangent is cosine over sine. And let's see, in order to create root 3, I would need my numerator to be root 3 over 2 and my denominator to be 1/2. And of course, one of those has to be negative. I'm in quadrant 2, so that's going to make the cosine negative, right? X is negative in quadrant 2. Okay, so we need to think about, so cosine maps to the x, and it's longer. So I know that I need this angle measure right here that's longer. It's longer along the x because cosine is x and root 3 over 2 is bigger. Okay, so if it's root 3 for cotangent or tangent, or root 3 over 2 or 1/2, we know it's the 30, 60, 90, guys. 30, 60, 90. So I know that's the angle that I need to, that's my answer, but I'm going to have to count to get over there unless I have it memorized. So I'm going to count. And do we recall, what do we count in to get to 30, 60, 90s? Sixth. Pi is over 6. We count in 6. So we got 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So this angle measure is 5 pi over 6. Yes, ma'am?
How did we know that it was in quadrant 2?
Because if we go back to, let me see if it'll behave and scroll with me. If we go back to this little guy right here, we see the arc cotangent is only allowed to be in the first and second quadrant. The first quadrant would be where the argument was positive, and the second quadrant would be where the argument was negative. So we would have to memorize this. You would have to memorize this schematic. All right. Let's go back. Okay, any other questions on number 2? Okay, let's move to number 3. So when we're dealing with these, see how they're functions inside of functions, which are called composite functions. You may or may not remember that from last year. When we are dealing with composite functions, we need to work from the inside out. So I'm going to focus on the inside right now. I'm going to focus on what does that mean. So this number is negative. This is a negative number. So I'm going to have to choose the quadrant. Where is arcsine negative? Quadrant 4. So my choice is quadrant 4 because I've memorized that little graph. So let's draw, well, actually, we're in quadrant 4. Okay. Is negative 2/3 a unit circle value? No. So we're going to write right here. This is a note. Note, if not unit circle, must draw triangle, period. If it's not unit circle, you have to draw a triangle. Our triangle has to be in the 4th quadrant. That's what we just figured out. So we're going to draw our triangle in the 4th quadrant. Okay. We have to do our SOHCAHTOA thing, right? Because this is sine. So sine is opposite over hypotenuse. So opposite is 2. Hypotenuse is 3. And one of those numbers has to be negative. The hypotenuse is never negative, so the 2 is negative. Okay. We need the third side. So we do our Pythagorean theorem for the third side. So I've got negative 2 squared plus b squared equals 3 squared. So b squared is what? 9 minus 4 or 5. So b is root 5. Okay, so I'm going to pause there for just a moment. So all the work that we have done has been focused on the inside part where arcsine is negative 2/3. And we have drawn that picture to represent the yellow. Okay? Now our job is to read tangent off of this table. We're going to read tangent off the triangle. Okay, why are we reading tangent off the triangle? Because this is tangent of the triangle. This is what this is telling us, tangent of that triangle. All right, and why did we have to do the triangle? Because that's not a unit circle value. Okay, we all together? Okay, so now I'm going to read tangent off of the triangle. Tangent, SOHCAHTOA. Tangent is opposite over adjacent. So opposite over adjacent, and that's my final answer. There is no need to rationalize unless you just want to. You can do it if you want to, but it's not required. And I don't even think the homework program requires you to. I don't think it does. So, all right, is everybody okay with that? Okay. Number 4, similar. We're going to, it's a little different. Notice how on number 3, the inverse function was on the inside of the parentheses. On number 4, the inverse function is on the outside of the parentheses. It doesn't matter. We're still going to work on the inside first. We are still going to work on the inside first. So, here we go. I'm going to highlight the inside. That's what we want to focus on. I'm very visual. I have to draw a picture. You guys may already know what this is perfectly. Now, some of you are like, oh, wait, doesn't arcsine and sine cancel out? Kinda, but not exactly all the time. So we need to check it out. I'll explain why. So let's figure out where 7 pi over 6 is. We're going to have to count 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6 is right here. That is 7 pi over 6. Okay, so we need to figure out sine is mapped to the y. We need to figure out the y value at that location. Sine is mapped to the y. This is a 30, 60, 90. If you recall, for 30, 60, 90s, right, we've either got root 3 over 2 or we got 1/2. I mean, that's all there is. Root 3 over 2 or 1/2. So, and these are negative, right? The third quadrant, everything is negative. So it's going to be some negative thing. Let's see. That's longer along the x-axis, which means the x would be bigger. Cosine would be bigger. So sine would be smaller. So what is sine of 7 pi over 6? Negative 1/2. It is negative 1/2. So let's write that down. We know sine of 7 pi over 6 is negative 1/2. Now, it would have been great if I could have canceled the arcsine and sine out and said my answer was 7 pi over 6, but what would be wrong with that? What's wrong? Where am I? I'm in the third quadrant. Am I allowed to be in the third quadrant for the arc functions? Absolutely not. Absolutely not. So my job then is going to have to figure out, where do I go? So where is arcsine supposed to be? So we have to ask ourselves, where is arcsine negative? Where is that? Something we memorize, right? Where's arcsine negative? Quadrant 4. Okay, I need to be in quadrant 4. That's where I need to be. Okay, I need to have an angle in quadrant 4 that would give me a y value. My y value needs to be negative 1/2. That's what I need to be. If the y value is the smaller one, I've got to have it longer along x. That is the angle measure that I need. Does everybody understand why y would be negative 1/2 there? Are we all okay with that? Okay, so this is still 30, 60, 90s. I still count in sixths, but I'm going to count backwards now. Remember, when we're in the fourth quadrant, we are not allowed to go through the third quadrant for our function values, which are also called principal values. Okay, so we're going to rotate backwards. And that's just one spot. I mean, that's just negative pi over 6, negative 1 pi over 6. So if we simply did arcsine of sine and canceled it out and got an answer of 7 pi over 6, that would have been incorrect. Why would it have been incorrect? Why would that be wrong if we did arcsine of sine and got our answer of 7 pi over 6 and just canceled those things out? Because 7 pi over 6 is in the third quadrant. It's not allowed to be there. Okay? Questions? Okay. Now we have the super fun number 5. Okay. Let me get to, are we okay with this, ladies? Let me talk about number 5. Number 5 is like the hardest one. It might even be the hardest one, you know, in the whole chapter. I don't know. People have trouble with it, so stay with me. You got to stay close with me. Okay? I actually wrote out steps. I wrote out steps because, you know, I mean, we like steps. Do you like steps? I like steps. Okay, so here we go. I'm going to write steps to the right, and I'm going to do the work to the left. Okay, so step number 1. we want to let whatever is inside the parentheses equal to theta. Now, I'm just going to be honest with you. I taught this in the last class, and some students were skipping this part. If you skip this part, you're not going to be able to do the lesson. This kind of problem. I'm just telling you. You have to do this. Okay? So I'm going to let whatever's inside equal to theta. Okay. So I'm going to say theta equals tan -1 of u. Then I need to convert to a u equals immediately. I need to do these first and second. Please do not skip this step. So I'm going to put an arrow here, and I know that if I switch the theta and the u, I am making the inverse. So tangent of theta equals u. This is significant. This is going to guide you through the whole rest of the problem. And if you haven't written it down, you won't have any guidance. Okay. Okay so far. All right. Step 3. We want to replace whatever is inside the parentheses with theta. Why? I just said that theta is the same as arctangent. So I'm going to substitute. I'm going to take out the arctangent and I'm going to put theta in its place. This is the problem that I'm going to work. Some students were going straight to the problem that they were going to work, and they didn't know how to work it because you have to have steps 1 and 2 to know how to work it. Okay. So, what is our 4th step? We need to turn everything into whatever we had the u. So in this case, tangent theta. We need to turn everything into tangents. I mean, that's our goal. Why? Because in the end, we will replace all tangents with u's. We're not going to have any trig functions left. We're going to replace all the tangents with u's. Okay. So I'm going to pause here for a second. Are we okay so far? Why are we doing this? That's why. Yes, ma'am.
So if you gave this to us on a test, it'll have sine and tangent too?
No, it will have different ones.
So we'll just know by what's in the parentheses?
Yes, and so that's what you have to do. You have to go by the parentheses. Whatever's in the parentheses. So let's say secant was in the parentheses. That means you need to turn everything to secants.
Okay.
So you can make them u. Whatever's in the parentheses, that's what you need to turn everything to. Now, unfortunately, or fortunately, I guess however you look at it, it's not always a straight step. What are your options? What can you do? So let's list some things. What can you do? Okay. We'll call this A. What can you do? You could rewrite using reciprocal or quotient identities. Okay, so I could turn sine into 1 over cosecant, or I could turn sine into, 1 over cosecant is probably the easiest thing. I could do that. B, you could multiply by a clever form of 1. Clever form of 1. So I need a tangent, so maybe I should multiply by cosine over cosine. I think that might be helpful. And C, you can relate to Pythagorean identities. Those are the main ones. There's really not much left. We do need to write out the Pythagorean identities. Perhaps I'll write them over here. Okay, so we know sine squared plus cosine squared is 1. If I divide everything by sine squared, I get 1 plus cotangent squared equals, let's see, 1 over sine is cosecant squared. If I divide everything by cosine, I get tangent squared plus 1 equals, what's secant squared? Okay, so these are a key last resort. Okay, I want to pause here for a second. That's I got lots of steps because there's a lot going on. Like I said, this is like very complex. And what I would recommend that you do when I'm done with this is that you log into your homework and do these problems first while we're all together. I would highly recommend that. I think there are 4. I think 4 of the problems are like this. Okay? So let's look at what we have and see what we should do. Rewriting sine is 1 over cosecant. I don't see that helps me get to a tangent. I need tangent. That's what I need. Now I have that bracketed. I need tangent. Okay, I know tangent is sine over cosine, so probably doing step B, multiply by a clever form of 1. Let's try that. So I'm going to multiply by cosine over cosine, because that's multiplying by a clever form of 1, and that gives me, let's see, sine over cosine is tangent cosine. Okay, well, great, we have a tangent. We still have an issue. We got a cosine. Okay. Let's look at this identity over here. Tangent and secant are related to each other in this Pythagorean identity, like part C can relate to Pythag. Okay, so what if I turned cosine into 1 over secant? Would y'all be okay with that? I'm using an reciprocal property. So I have tangent theta over secant theta. And I'm going to pause here for just a moment. Is everybody okay? So my numerator is great. That's going to turn into a u. I am very happy about that. My denominator is not quite ready. Not quite ready. So what I want to do is I want to go over here to these Pythags and show you what you would do when you see that it's related. I want to replace secant with tangent squared. Look at how this is written. I see, so I've got tangent squared plus 1 equals secant squared. What would happen if I square rooted both sides? Can you square root both sides of an equation? Yes? What's the square root of secant squared? Secant. So secant is going to be, let me get some room over here. Okay, so this is how we utilize the Pythagorean identities. So secant is going to be the same as the square root of tangent squared plus 1. Okay. So what I'm going to do is I'm going to go over here and I'm going to replace. So this is going to be the same as, I have tangent in the numerator. In the denominator, I'm going to replace secant with the square root of tangent squared plus 1. I want to pause here for a second. I have now accomplished my goal of making u tangent. And notice in doing that, I am really digging into my identities. which is something that, you know, it's going to have to be memorized, right? Because we're going to use that forever. Okay, something has to be memorized. Yes, ma'am.
I'm just confused where you got secant in the denominator from.
I know that, so I took a look at this little guy right here. I know that, let's see where I can write it. I know that cosine is the same as 1 over secant. So I replaced cosine with 1 over secant. Is that okay? Okay. Other questions before we do the last step? My last step is this y step. This right here. This is the last step. Because in the end, we're going to replace all the tangents with u's. That's the final goal for us, is to get rid of all of the trig and put u's in there. So u over square root of u squared plus 1. This is my final answer. So this problem is a journey. It's a journey. You're like, oh, great, I can't wait for the journey. I need to give you a caution. I need to give you a caution. Okay. The caution has to do with, so is everybody okay with this? Can I go back to the top? We all good? Okay, I need to go back to look at this table up here. The caution that I want to give you is arcsine, arctangent, arccos, well, those are good. It's the blue ones. Arc cosine, arc cotangent, arc secant. Those are issues because they have to remain positive. Do you see how they're in the first and second quadrant? Those angle measures are positive. You with me? Angle measures are positive. So there was a homework problem that the ladies were doing previously where they were turning everything to secants. Maybe it looks something like this. I don't remember. Was it 1 minus secant theta? Secant theta. Maybe it was secant theta plus 1. I don't remember. Okay. When they converted this, so this is just an example. I'm just showing you the danger. Okay. They had secant theta being u. This was the the inside part. The inside part was secant instead of tangent like we're doing now. Since secant has to be positive, you just saw it has to be in the positive angle measure. When they converted this to u's, it became u squared plus 1 over u. But the computer is very fussy and wanted it to be absolute value of u. I just need to warn you, and that's with the secant one only. If it's secant, or what were our other ones up in the top that can be positive? It's cosine, sine, cosecant, and hold on, let me get back up here. The ones that have to be positive are cosine, secant, and cotangent. Cosine, secant, and cotangent. If you're left with just that, you have to absolute value it. Why don't I have to absolute value inside the square root? Why don't I have to absolute value that secant? Because it's being squared, and that's going to force it to be positive. I don't have to absolute value that one. Does that make sense? So I just need to give you the heads up, because that took, actually, it surprised me that they were being that precise, which is fine. I mean, it's fine. I'm surprised that they're forcing us to put absolute values there, but they are. So beware. Okay?